So here's what we're going to do. We're going to take this function right here, and so by the remainder theorem, it says if we evaluate this function at one of its roots, and we'll talk about what that means in just a second, that it produces the remainder of this function. So what we mean by a root is I'm telling you guys that this x plus 3 thing, so I'm telling you guys that this is a factor. Okay, that I'm gonna divide. I want to find out. It's not. I shouldn't say it's a factor. I want to divide it into it. Okay, and the way I do that is I'm going to use this process called synthetic division. And synthetic division is really nice when you can use it. It's a special case. We can't use it all the time. So there's a couple requirements. Really just one requirement. What I'm dividing by must be a linear term. Reminder what a linear term means. It means that the exponent has to be 1. Okay, it can't be 2 or 3 or anything else. It can only be a linear term, so it's going to be like x plus 5 or x minus 7. It's got to be of that form. It can't be x squared plus x minus 8 like we've been doing. Okay, it has to be a linear term, this binomial that we're dividing into this function. So if it fits this qualification, then we're going to use a process called synthetic division. Synthetic division is so nice. So here's what we do. The first thing we do is we ask ourselves, what would x have to be in order for this whole thing to equal 0, for that little expression to equal 0? What would x have to be? Negative 3. So what I'm going to do is I'm going to put a negative 3 right here. Then I'm going to do an upside down long division sign. Now, what I'm going to next do is I'm going to grab the coefficients from my polynomial. So I'm going to grab the coefficients. Same thing like when we did long division. If I skip a term, right, my exponents have to go down by 1s. If I skip one, I have to put a placeholder of 0. This time, though, I'm only going to put the coefficients, no x's. So my first coefficient is 2, then it is 1, then it is negative 8, then it is 5. I didn't need any zeros because I never skipped anything. Okay? So now I am set up to do my synthetic division. So here's how it works. The very first thing I'm going to do is I am just going to bring down this 2 and put it right there. I'm just going to bring it down. Boom, it's down. Okay? Next, I'm going to take the negative 3 and I'm going to multiply it to the 2 and I'm going to put it right here. So negative 3 times 2 is negative 6. I'm going to put that right there. Okay? Now, I add the column. So I'm going to add that 1 in the negative 6. I'm going to put it right below. So 1 plus negative 6 is negative 5. And I'm going to put that right there. At this point, the process repeats. So I'm going to take that negative 3, multiply it to the negative 5, and put it underneath the negative 8. So negative 3 times negative 5 is positive 15. So I put that here. And again, I go through the process. Negative 8 plus 15 is 7. So that goes here. And then I do it again. So I'm going to figure out what goes below the 5. And someone help us out. What goes below the 5? Negative 21, because I take negative 3, multiply it to 7. So negative 3 times 7 is negative 21. I add them together, getting negative 16. Now this negative 16 is my remainder. Now here's what's cool. Here's what's cool. I'm going to go back and write this polynomial. I know that's the remainder, so I know the 7 has to be the constant term, the negative 5 has to be the linear term, and the 2 has to be the squared term. So in other words, my function's going to look like 2x squared minus 5x plus 7 plus my remainder, which is negative 16, over to my divisor. What was my divisor again?
X plus 3.
X plus 3.